Hi guys, welcome to Unit 11. Unit 11 deals really with the solar system and from early observations and how we basically came up with a new, especially the wandering stars, namely planets, how they move around the sun. Remember, up to Mr. Copernicus before him, the view was that everything revolves around the Earth, including the sun itself. And when we explored the old idea, especially from Mr. Maybe, that the Earth is actually revolving around the sun, including with the other planets too. That idea was rebuffed immediately because of the fact that we cannot observe parallax. When Mr. Copernicus was asked to basically fix the calendar around the 16th century, he made some observations, and those observations basically led him to revise that view and return back to the original point, namely the fact that the sun is the center of the solar system, and all the planets, including the Earth, revolve around the sun. So let me share with you the screen. So again, so all the planets are revolving around the sun. This is due to meticulous observations that he conducted. And I will go a little bit, that really was the biggest contention point was the issue with the retrograde motion of Mars. Mars, at some point during the year, seems to move in the opposite direction as other planets, or other stars for that matter, against the background constellations. As you can clearly see from here, you have Antares, which is a star, and it starts its retrograde motion sometime between basically in the middle of the year and return back to its normal motion. This is from the starting in February 2016. This is the motion is in this direction all the way toward the end of the year. So sometime during the year, Mars exhibits this motion, and it's really exaggerated as compared to other planets, which also do the same thing, but their path in the retrograde is a little bit small. So in order to explain that, the whole model of the fact that basically resides on the issue of how things revolve around the Earth was basically developed by Mr. Ptolemy, in which he put all of the objects, including the moon and Mercury and all of the planets, and also the sun, in orbits around the Earth, in circular orbits around the Earth, and that explains basically the daily motion of all of these objects. That's the perspective that he had. This is called the geocentric model because the Earth is the center of the solar system. So all of the planets, including the sun, revolve around the Earth. And way back in the background, there are those stars that don't move, that they decorate basically the night sky, namely the remaining wandering stars. I mean, the fixed stars, they don't do that. They stay stationary in their constellation throughout the year. Here is the interpretation of the retrograde motion according to this model. Ptolemy had to add another path for Mars to account for its retrograde motion. And that path basically, as it revolves around the Earth, takes it at times through a circular path on its big circular path, namely then that circular path, its center goes around the Earth in a circular path too. So that, in a sense, explains the retrograde motion. For this to happen, you have to understand that this retrograde motion is real, meaning at times the planet Mars can move, is moving forward with respect to the Earth, it's moving in the backward motion. So this is a real motion. Obviously, when we learned about forces, the question was, how come, what force makes it do so, because this is a real motion, so we really have to explain it. There was no explanation in the heliocentric model, where the sun is actually the center of the solar system. Then in this case, all we need is the force of gravity that maintain all of the planets towards the sun, including that of Mars. So Mars, and in this case, retrograde motion is not real, it's virtual. Basically, it's perceived and not real. In a sense, the Earth is closer to the sun. The Earth moves faster than the sun because its proximity to the sun. It's like when you have the rubber ducky in the tub, when you pull the plug underneath, things that are closer to the where the water is going move faster than the things that are further away. And that's exactly what's going on. So Earth, at some point during this position, when Mars is going to a position that is called the opposition, the Earth is overtaking Mars. So in that case, Mars starts to appear moving backward. Then after that, when the Earth moves to the other side of the opposition, these positions are called the quadratures. So when it's in the opposite direction, when it's moving from this quadrature to the other quadrature, in that case, the Mars appears to be moving forward back to its normal path. So this is an explanation, and that's because the speed of the Earth around the sun is faster than the speed of the sun. So there is a natural explanation for the retrograde motion without the need of that epicycles and external forces that we have no explanation for them. So this retrograde motion in this model, in the heliocentric model, is virtual, not real, okay? Hence does not require any additional forces, okay? Here is the observations that Mr. Copernicus basically based the geometry that he used. Objects that are on the opposite side of the Earth, when they're in their opposition, that is where they're closer to be or have been into the retrograde motion. So that includes not just Mars, but also Jupiter, Saturn, and all of the other planets, and all the dwarf planets like Ceres. Planets that are in their inside, like Venus and Mercury, they also do retrograde motion when we are toward the second part of the inferior conjunction. So this is called the inferior conjunction, when the Earth, the planet, and the sun line up. The superior conjunction is when the planet is the opposite side, when the sun is between the Earth and the planet. The opposition is when, again, the Earth is between the planet and the sun. And this is a pattern that is true for all of the other planets. Quadrature is when the Earth and the planet, like Mars in this case, and the sun form a right angle triangle. In a sense, the angle between the Earth and the planet and the Earth and the sun is 90 degrees. So using these observations, Copernicus came up with this data. I can let you guys go through the details, but this is basically the data that is really something interesting in here. He came up with the distance from the sun to the to Mercury to be about 0.38 astronomical units. What an astronomical unit is, the distance from the Earth to the sun. So it's about 40% the distance from the Earth to the sun, just a little under halfway, okay? For Venus, he came up with slightly less than 3/4 of the way, 0.72. What we know today is actually the number for Venus is exactly correct. It's slightly off, but it's a very, very acceptable value for Mercury too. Mars was immaculately correct. Jupiter was off. But that's very good actually for those observations those days where you didn't have a lot of equipment, when telescopes were not available and you have to use things with the naked eye. So this is a very good basically measurements and very good results. Saturn was a little off though, from 9.17 astronomical units, basically 9 times the distance to the Earth and some change, to about 9.5, the current value that we know of that distance between the sun and Saturn. That Saturn is almost, slightly more than 9.5 away as the distance from the Earth to the sun. So these are the data, these are the observations. This is the main points from unit 11. Let me stop sharing.